Today we are going to talk about Java 9. Obviously, the timing of this works really well since Java 9 came out last week or the week before, very recently. And with Java 1 going on this week as well, there's an awful lot of noise around Java 9, what it is, and how it's going to impact us as developers. So in this webinar, that's what we're going to cover, as Andre said. So what I always like to do with my presentations is I like to take the features which are relevant to us as developers and show how we're going to use them in our real day-to-day jobs. So that's why I've called it Real World Java 9. We're going to have a look at Jigsaw, of course, being the big ticket item for Java 9. We're going to have a quick look at the Reactive API in Java 9. And then we're going to cover everything else. Unfortunately for Java 9, for Java 9's branding, the fact is that Java 9 has a lot of different types of small changes that make a difference to us as developers, but they don't fall under one nice umbrella term. So basically, we're going to cover everything else, whatever that is. We don't have a lot of time. So as Andre said, please feel free to put all the questions into the webinar question box, and we will try and address them at the end. But what I would like to do is try and cover as many of these features as possible during the presentation, and then leave a lot of the questions for the end. Firstly, of course, the question is, why Java 9? Other than the fact that it's the latest, greatest thing and we've been waiting for it for 3 years, why do you want to upgrade your code to use Java 9? Well, as usual, they've worked really hard on things like performance. So even if you don't use any of the new features, any of the new syntax, anything, you should get a free better performance, particularly around use of memory. They've changed the way that strings work, so that can take up to half the amount of memory it used to. You get better performance of locking, secure applications, graphics. This is particularly useful, really, for the IntelliJ IDEA side of stuff as well. We've been able to use some of the Java 9 features to be able to improve the graphics of the application itself. Better documentation, better use of hardware in terms of CPU operations, faster compilation. So even without using any of the features we're going to talk about, using Java 9 will probably speed up your application or the compilation of your application. So it's kind of interesting from that point of view. Other than that, when we think about Java 9, we tend to hear about Jigsaw, of course. We might hear a little bit about the REPL, JShell, which we'll look at in a minute. And then we're not really sure if there's anything else that's interesting in Java 9. It seems to be that we've taken, I don't know, nearly 10 years to produce Jigsaw, and what else is there in Java 9? Well, there's one or two things coming into Java 9. As I said, there's a lot of features that don't necessarily all fall together under the same umbrella. So, and there's a lot of things that they've done in the back end in terms of how they improve the way that they develop the JDK itself. So a lot of stuff that isn't necessarily visible to us as developers, but will allow us to get, for example, better quality builds faster, that kind of thing. So we will take a look at some of these features in this presentation. The case study we're going to look at, I like to use real code for these sorts of things. We can use snippets of code if you like, but I like to use real examples, a real application, so that you get a feel for what it's like to work with in the real world. Some of you may remember a couple of years ago, I used this demo of a JavaFX UI that's listening to Twitter, responding to data in real time, and then updating that JavaFX dashboard in real time. This was designed to demonstrate a lot of the Java 8 features, like lambdas and streams. So what I wanted to do is take this application and see what benefits it might get from using Java 9. In particular, what's interesting about this is it's architected as a series of small services. So some of this might be useful in terms of things like the Reactive API. If you're interested in the original application, you can see, for example, the webinar I did on that at this URL, loads more information. So I'm not going to go into it in any detail because that's already been covered in a previous presentation. So let's just dive straight in. The thing that we're kind of most afraid of potentially is how hard will it be to take my existing application and compile it against Java 9. So let's address that straight now. Let's address that head on before we go any further. So here's my application. This is the application as it was before I did any migration. So if I rebuild this project, let's see what happens. Firstly, what it does is it takes a little while to build so that I sound very quiet on the webinar. As it's building, it should be able to give me some of the errors. So one of the first things which may break your code if you were doing this is, apparently, underscore was a perfectly valid identifier in Java 8 and pre-Java 8. I think a lot of people didn't really realize this, and now they see this, they think, oh, that's quite cool. I could use that for all sorts of nasty little hacks. But as of Java 9, this is no longer valid as an identifier. This is probably going to be used in later versions of Java for things like maybe making lambda expressions easier to work with. So, of course, to fix that, all you need to do is you just need to do a rename. Let's check. There we go, rename. So you want to call it something more useful. As I'm using the keyboard shortcuts for IntelliJ IDEA, you should see them pop up on the bottom with the presentation assistant. So of course you just have to rename that to get that to compile. Just to clarify though, underscores are still valid inside the name if you want. They're still valid at the front of the name if you want. And if you really, really want, you could still do double underscore, but that's kind of nasty, so I do not recommend that. So you want to call this something useful. Rebuild it, see what happens. Now we're going to start to see some of the errors that we've been told about. We've been warned about this as people have been talking about Java 9. One of the main points about Jigsaw and modularity is the ability to better encapsulate your code, to add a level of protection between package private and public things. And one of the things that's going away is internal APIs inside the JVM itself. So anything that started with sun.misc, we shouldn't have been using that in the first place, but some of us were. This is genuine code I was using in my previous application, and I was using this base64 encoder because it did what I wanted it to do, and I was too lazy to find out what I should have been using instead. But Java 8 will warn you, you shouldn't be using this because this is an internal API and it is going to go away in a later version. So let's get rid of that because we don't want to be using that. And let's replace it with what we should be using instead. In this case, what we should be using is base64, java.util, get encoder, encode to string. And then that will all work the way it used to before. And if I recompile, my whole project should compile correctly now. So I had to do just two very small things to try and get my project compiling. And both of those things will give you warnings. When you're compiling it in Java 8, you'll see warnings anyway. So you can migrate your code to be ready for Java 9 while you're still using Java 8. And as I said, things like the sun.misc packages, you shouldn't have been using that anyway. There is an exception. You may have heard that sun.misc.unsafe was going away. And that's not necessarily the case because sun.misc.unsafe doesn't have a one-for-one replacement in JDK 9. So they couldn't remove unsafe in JDK 9 because there's nothing to replace it with. And although you may not be using it in your code, some libraries and frameworks were using it. But what you do need to do is you do need to say, yes, I really do want to use unsafe. I know what I'm doing. So that's why it says it's declared in module jdk.unsupported. But it's still there, but libraries and frameworks will be moving away from using that. So now our code compiles, and that really wasn't quite as challenging as we thought it would be. So let's go straight on to Jigsaw. This is the big ticket item for Java 9. Jigsaw actually is the name of a big project which encapsulates a number of different features, a number of different bits of functionality. So Jigsaw includes breaking the JDK itself into different individual modules. It includes things like the ability to encapsulate these internal APIs so that they can be hidden away. So not only breaking the JDK into modules, but also taking things like the sun.misc API, code, and hiding that away so you can't see it anymore. And then, of course, there's the module system itself. So they used the module system itself to create the modular JDK. And this is also the thing that we're going to use in order to add modularity to our own code. The other thing that's under Project Jigsaw is JLink, which is the ability to, instead of having to deploy all of Java, this whole massive thing with everything, including Corba and AWT and everything else you don't use, along with your application, JLink will allow you to pick up just the modules that you want and deploy a much smaller profile of Java for you to run your application on, which can be super useful for keeping costs down, for improving deployment times, and that sort of thing. But mostly what people are thinking of when they talk about Jigsaw is they're talking about the Java Platform Module System, JPMS itself. So this is the thing that has been added to Java to allow us to create modules in our code itself. So I want to step through how I turned my previous Java 8 code into Java 9 modular code. This was my original project structure. As you can see, I have IntelliJ IDEA modules. These bold things are IntelliJ IDEA modules.
I'm sorry to interrupt.
Yep.
I'm sorry. It seems the screen sharing is frozen. Can you check it?
What are you seeing at the moment?
There is a warning about the unsafe package.
Oh, okay. Oh, that's a while back then. That's fine. Let me try and fix that. Hold on a second. Can you see a slide which says Jigsaw?
Yep.
Excellent. Okay. So you haven't missed that much. That's fine. What I had, I'm hoping you can't see my GoToWebinar control panel. I'm assuming that's hidden. Okay. When I was talking about Project Jigsaw, these are the different individual items that make up Project Jigsaw. As I said, there's the modular JDK itself, Encapsulate most internal APIs, JLink to allow you to create a much smaller version of Java to deploy, and the module system itself. So we're going to look at the module system itself. Here is the package structure of my previous application. This is when I was running it under Java 8. And you can see I've got IntelliJ IDEA modules here. I've got a dashboard. I've got a service module, which is reusable infrastructure code, which should be used by all of my services. And then I have everything else. And for some reason, this made sense to me when I was creating this application. But in actual fact, this doesn't really make quite as much sense as I thought, because I actually have 3 backend services, which implies I should have 3 modules for those 3 independent pieces of code. If I put them all into a single module, they can be dependent upon each other in terms of code, and they shouldn't be. So when I decided to apply the JPMS to my existing code, I broke it up into a much larger number of modules. So I still have my UI module, I still have my service module with infrastructure code, I have a new module with some stuff around my Reactive API, and then I have 3 individual modules for my 3 individual services, which makes a lot more sense. The other thing you might notice is that each of my modules has a module-info.java file, and this is how we tell the JVM that this is going to be using the Java Platform Module System, and that this is basically our module descriptor. This says what our module is, what it needs, and what it exposes to the rest of the world. If you look at demos and samples and stuff, you might see some tutorials suggest that you have a structure which looks like this, which has got a source at the top, and then a series of modules inside, and then a test at the top, and a series of modules inside that. That's the OpenJDK structure. We don't have to do that. We can use a more Gradle/Maven style way, where we have a module at the top, which contains a source directory and a test directory. It doesn't really matter which way around you do it. As long as your module info file is inside your source directory, or the directory which you declare as your source root, then it will work. It'll be fine. So let's take a look at what this module-info.java file is. It's kind of an odd structure of a name for a Java file. Normally we have camel case with uppercase, and we don't have hyphens in. Let's change to the correct branch. Okay, so you can see all my modules here. I've got my UI module, I've got my service module, and a bunch of others. Some of these have already been turned into Java 9 modules. I'm going to go through the process of turning this flow module into a Java 9 module. And if I build this at the moment, in theory, everything should compile correctly, even though I have some Java 9 modules with the module info and some IntelliJ modules that haven't defined module info. Everything should still work and play nicely together regardless. Which it does, which is good news. I was a bit worried for a second there. So we can use IntelliJ to create a new module info file. IntelliJ will by default take the name of the IntelliJ module and use that as the name of your Java 9 module. First off, without doing anything else with this file, let's rebuild it and see what the impact is from rebuilding the project. Now I have a modular file. Now what happens now is we get a load of compiler errors. And this might seem kind of weird because we had a project which was working perfectly acceptably, and now all we've done is added a single file and suddenly things don't compile properly. But there's a fairly rational explanation for this, of course, as you'd expect. Let's go back to our module info file. By default, module info files have this concept of importing java.base. Okay, so this says anything in java.base I get access to for free. I don't actually have to say that in my module info file. I will get access to that for free. And the stuff that's in there is things like java.util, java.lang, and the stuff that we kind of are bound to use, things like string, all these things which are really important for us to use in day-to-day programming. But that's just the very, very basic things that we need from the JDK. So if we want to use anything else, then we need to say, well, we want to use the module that contains those things. In this case, I'm using logging. So I need to use the module java.logging in order to be able to use the logger. So I'll use IntelliJ to do a quick fix for this. If I go back to my module info, I get requires java.logging. And if we look at this, let's drill into it. We can see now that the Java 9 JDK, instead of just being broken down into packages, it is broken down into modules, and each of these modules has packages inside it. So the java.base is obviously the stuff that we get by default, and I've just said I also want to be able to use java.logging, which gives me access to java.util.logging. So that's one error fixed. Let's go to another error. There's one more thing here, which says org.reactive streams is declared in module reactive.streams, but flow does not use it. So I also need to do this for external libraries as well. Obviously, I'll just get IntelliJ to fix it for me because I'm lazy like that. And if we go into module info, now it says requires reactive.streams. And this might seem kind of weird because the question is, where did this come from? This is clearly not in the JDK because it doesn't start with Java or JavaX for a start. So where did this module come from? And if I drill into it, this is an external jar file, reactive-streams-1.0.0.jar. What Java 9 does is it takes external jar files, it strips off any version number on the end, turns things like hyphens and underscores to dots, and then uses that as the module name. And then this is something called an automatic module. So things like external jar files are kind of treated like they were modules, even if they don't use Java 9, even if they don't have a module-info file in, even if they're not truly modular. They're treated as automatic modules, which allows us to migrate our code to using the Java module system without being dependent upon everyone else having done the same thing as well. One of the nice things that got introduced in the late stages of Java 9 is these module names need to be unique, and library developers can declare in their manifest, they can declare what their module name would be if they were using Java 9. So it might be that it's not the jar file name, which is good because we know sometimes jar file names can be creative. Some of the library developers may choose to tag their jar file with a module name. So that allows us to migrate gradually towards using Java 9 modules. So now if I rebuild this, let's see what happens. This is all working. But what happens if I want to use any code from inside my flow module? Well, let's try using it from inside my user module. Let's do the same thing. Let's create our module info. Let's fix up the errors that we have. I'm just going to add these things to the module info. So then you'll see that this one has a very similar sort of setup to the other one that we just created. And then this one says, package sense.flow is declared in module sense.flow, which does not export it to module sense.user. I want to see if there's a quick fix on this. Oh, no, there isn't. So what this means is I know where this package is, I know where the class is, I know which module it lives in, but that module hasn't allowed me access to that class. So you can't use it. So what I need to do is in here, I need to say which packages I allow people to use. So I'm going to export flow. I want people to be able to use everything that's inside my flow package. That's my public API for my module. Note that if I have an impl package, then I can keep that secret and private, and no one else can use my impl package. And this applies to reflection as well. So people can't even reflect over my code. They can't use it at all if I haven't exposed it. So I can say I export this package, or I can even be more specific than that, and I can say I export it to a specific module. So I export it to user. Only the user module can use my flow module, for example, if that's what I wanted to do. And if I want to allow people to reflect over my code, then I have to open it. So I can open my, at a package level again, I can either open it to everyone to be able to use reflection, or I can say I open it to, again, some module to be able to reflect over it. And this is the power of Jigsaw. Not only do you get the ability to separate your code into individual modules and individual pieces, but you get a lot of control over what's visible and what's not visible, which gives you obviously better design, but also better security as well. So let's rebuild that and see what happens. And let's go back to our user service. So now our user service, all we have to do is say that we're going to use the flow module, and then everything will work. So that's a quick intro to applying modularity, Java 9 modularity to your existing code. You need a module info file. You need to declare which modules you're dependent upon, whether they are JDK modules, whether they are automatic modules, i.e. these external jar files, or in the case of the user service, you might be requiring one of your own modules. And you also need to be able to declare which packages you allow people to see. So in the case of my user service, for example, I don't let anyone else see anything in there because that's just a standalone service. It doesn't have any code that I want anyone else to be able to talk to. In a slightly more complicated example, oh, well, I'll come back to that in a minute. Let me switch branches so I can show you a more complicated example. So a slightly more complicated example is this one here. This is my UI code. So my UI code, obviously, I require JavaFX modules from the JDK itself. And what I actually need to do is I need to open up my code to reflection because the FXML functionality uses reflection to basically to work basically between my Java classes and my FXML classes. So it's a slightly more complicated module, but you can see here the sort of features that you're expecting to use. To create this particular module info file, I used brute force trial and error using errors that came up in the IntelliJ IDEA IDE, and also runtime errors that happened when I was trying to run things. I do not recommend using brute force trial and error to create your module info file. It took me a couple of days, and even then it wasn't tidy and it wasn't great. The best thing to do is get to understand a tool called JDEPS, which will analyze the dependencies in your code and will tell you which modules you're using, and therefore it will allow you to create this module info file much more easily and much more neatly. In the link that I'll post at the end of the presentation, there'll be some documentation. If you follow that link, there'll be some documentation about JDEPS and how it works. So that's a really quick tour of how to apply modularity to existing Java code. In terms of the pain, you might end up reorganizing the structure of your code. Jigsaw doesn't require it, but you might find that when you're thinking in terms of these modules, these independent pieces of code, that you might want to separate your code a bit more, like I did. I wanted to create 3 separate modules for my 3 separate services. So obviously structural reorganization of an application is non-trivial. The IDE support is obviously getting there. The last 4 or 5 versions of IntelliJ IDEA have incrementally added more support for Java 9 features in general and Jigsaw features specifically. But obviously, this sort of thing takes time, so you don't get quick fixes for absolutely everything. However, you did see that I can create my module info file. I've got quick fixes for adding the requires statements to it. I have code completion and highlighting, and a lot of the stuff that I expect to be able to get while working with any sort of Java file. So yes, so it works, but it's not like you can say to IntelliJ, create my module info and have everything work for you. If you are going to use modularity, do go and read the documentation. Do go and find out what it means, what the implications are. Find out about JDEPS and how it works, because it's a very big change to the language. It's one of the reasons why it took so long to create and to release Java 9. And it has other implications which we haven't really covered. Like, for example, with Jigsaw, when you're using the Java Platform Module System, you're actually using a module path, not a class path. So that's quite a big change. Like class path, you just put jar files on the class path and you end up with this big bucket of classes which gets parsed in some arbitrary order, and you can end up with all sorts of weird problems in terms of having duplicate classes, in terms of having version clashes, in terms of the performance of trying to parse this class path. One of the things that Jigsaw is supposed to solve is by getting rid of class path and using module path. It's much stricter in terms of what you're allowed to depend upon. It can do some analysis over, do you have 2 versions of the same class? You're not allowed to do that. Do you have packages which appear in more than one module? You're not allowed to have that either. Do you have modules with non-unique names? Then these things are all restricted. But that means that you can find some of the common errors, like method not found problems, for example. You can find common errors that would lead to that when you start your application up, not during runtime. So you get the Jigsaw allows you to fail faster. It gives you errors up front rather than having runtime errors. So it's really important to understand the full implications of using the Java module system, which means if you're interested in using it, do go and read all the documentation. And there's plenty of great books too. The gain, obviously you get cleaner design. I mean, we were probably creating modular systems anyway. You can use IntelliJ IDEA's modules, obviously, or Gradle or Maven to create modular design, OSGI. There's a lot of different solutions out there. But thinking about modules as a sort of first-class citizen of the language leads you, in my experience, it leads you to have better encapsulation, better separation of concerns, better object-oriented design. This is a good thing. Reliable configuration, like I said, the removal of the class path and moving towards module path means that you can get some of these common errors, you get them up front so you can fix them well before they end up in production. This is definitely a good thing. Smaller deployables. So I mentioned this when I talked about JLink. The point here is that Now we're in a modular world, we can pick and choose which modules we want to deploy, and we can bundle all of those up, just the modules we want, and deploy them into the cloud or onto an Internet of Things device or wherever we want to, and we can have a much smaller footprint of our applications, which is definitely a good thing. Right, let's move on really quickly cover the Reactive API, because this is now part of Java 9, and I think that's an interesting thing to at least be aware of. There's a mature, stable Reactive Streams API, which comes under org.reactivestreams. It has a publisher, a subscriber, a processor, which combines the publisher and the subscriber, and a subscription. And this is kind of the core basic building blocks of a lot of the Reactive libraries. And it's implemented by things like Akka, RxJava, Vertex, Reactor, a lot of the common Reactive libraries. So what's interesting about this is it's stable enough and accepted enough that it's now part of the Java 9 of the language itself. It's under Javadoc util.concurrent, and it's under Flow, and it looks the same as the Reactive Streams API. It is important to notice, though, that it's not exactly the same because it's in a different package and it has a different structure. So out of the box, RxJava, for example, is not going to be exposing the Java 9 Flow API because it's using the org Reactive Streams one. However, you can either use adapters to move between the two in the meantime, but I've also seen a number of the libraries that implement Reactive Streams, like Akka and like Reactor, have started to move towards using the Java 9 API. So I think this is really interesting because it means that reactive programming has become really quite accepted if it's actually part of Java, the language. It means that these reactive libraries can be talking to each other using the same API, which is part of the core JDK itself. I do have a lot of examples of using this and how it impacts the architecture of your application, but I'm not going to go into that in this particular presentation, but you can see a copy of that again in the link at the end of this presentation. There's some videos of that stuff as well, if you are interested specifically in the reactive programming side of things. Okay, that means we've got half an hour, or probably slightly less if we want time for questions, to go over all the other features in Java 9, which might sound like plenty of time, but it quite frequently is not. There's quite a lot of stuff in Java 9. Oh, actually, let's pause right now and see if there are any burning questions that need answering before we move on to this. Andre?
Okay, cool. So we have a couple of questions. So first question, is there Maven support for modules using the standard Maven folder structure, like
yes.
source, main, Java, and so on and so forth?
Yes, so there's kind of two questions there. If you use the classic Maven/Gradle structure of source main Java, will that work with modules? Yes, I have used that. That works fine. Two, does Maven work with Java 9? Yes, Maven has worked with Java 9 for quite a while now, and so it definitely works. I've used it myself, and it works fine. Gradle also works with Java 9 since Gradle 4.1. So the build systems are working with Java 9 now, including fully embracing modularity. So if you have a module-info file, you can build that with Gradle or with Maven.
Cool. Next question. Can you use the new model system for creating Android applications in future?
Theoretically, in future, yes. But Android's still Java 6, right? Ish. But Android's moving to the OpenJDK, so there's no reason why it can't adopt all of the same features which are coming in Java 9, which went into the OpenJDK, could eventually go into Android as well.
Yep. So basically, we don't know yet.
We don't know yet, but there's no reason why not, basically.
Yep. Then, do you plan to clarify the situation about using libraries without module-info? For example, about using Google AdWords APIs?
Using libraries without module-info. So this is basically automatic modules as far as I understand it. Automatic modules, what I wanted to do actually is I wanted to show, let me show you quickly the module diagram in IntelliJ IDEA. The reason being, I hope this will answer this question. If it doesn't, then I will try again. So this is a visualization of the modules that you're using. So this is my client module. I'm using my backend service module. The client module uses a bunch of JDK modules, all shown in yellow, and the service module uses a lot of blue external libraries. So these don't have module infos in. They are not proper modules. They're automatic modules. They're just external jar files. So this works, and the point is that your application can carry on using the same jar files it was using before, pretending that they are modules, even if you convert yourself to being a fully modular project. There are some risks around this, however, because there are, as I mentioned, things like the Java Platform Module System doesn't allow you to have things like the same package in multiple jar files. There are restrictions on the way you structure your code that weren't there in earlier versions of Java. So not all earlier versions of jar files, for example, are going to play that nicely with the module system. A lot of common libraries do. For example, I've been reading that Hibernate works fine, and that, like I said, Maven and Gradle works fine. Spring works fine. There's a bunch of stuff that just works fine with Java 9 without you having to do anything. But some libraries might not. So I guess my short answer is, if you're using automatic modules, and these show up as blue on these diagrams, it should work fine with Java 9. Automatic modules have been designed from a Java 9 point of view to be very flexible around how the code works, because it's understood that the code in those libraries is not Java 9 ready. But you may find that some libraries don't play that nicely because of the new restrictions placed on them by Java 9. Does that answer the question?
Yep, I think it does. Next question: how can we find all unsupported packages? Like you were showing the warning by the IDE about the unsafe package import statement.
So you use this tool called JDEPS. I don't really have a lot of time to go over it, but let's have a look at it. JDEPS Java 9. And actually, the Oracle blog does a good job of this anyway. There's a link to a tutorial in there. But if I look at the reference documentation, it's in Java 8 and in Java 9. That's module JDEPS. There we go. There's a link to this at the end of the slides anyway. So what you do is that it does a bunch of different things. You can use JDEPS in Java 8 against your Java 8 code, and it will warn you about any dependencies that you're not supposed to be using, like sun.misc. You can use JDEPS in your Java 9 code to see what your module dependencies are to help you build up your module info. So it's worth getting to understand what this tool does, because it will make your life a lot easier if you can understand how to use it. And it's non-trivial using it, but there's quite a few examples of how to use it out there.
Okay, cool. Then the module needs to be named the same as package name?
It doesn't need to. The suggestion is that it will follow reverse DNS the same as package names do. That is the suggestion. So it doesn't have to be called the same thing as the package, but it could be called the same thing as your artifact, if you like. As you can see, this doesn't apply to automatic modules because they were using the jar file name. But the suggestion has been to use reverse DNS for your package names. And I think this is to help you create unique module names.
Okay, so moving on with the questions. In Java 9, to take advantage of Jigsaw, is it recommended or required that packages are contained in a single module? I believe in IntelliJ IDEA module. Yes, Jigsaw module.
Is it required that the packages are in a single module? Don't quite understand the question, sorry.
Yeah, but maybe we can comment on that in one module you may have several packages, and that's the only constraint. Right?
So, for example, my client module has multiple packages, and I can choose to expose as few or as many of those as I want. My mood module just has one package, which is sense.mood. And again, I can choose to expose as many as few as I want. What I can't do is I can't have let's say in my flow module, I can't have a package called sense.mood because sense.mood is in my mood module. So I can have more than one package in my module. In this case, look, I actually only export one. I export my client package. I don't export any of my internal packages, but I can have internal packages there, and I could choose to expose one or more of them. And I can have, or I can have modules which are just made up of one package.
Okay. Then, is it correct that with modules I have to type twice the package names? Once a module requires part, the other is imports part.
Effectively, yes. In that, so let's have a look. So my dashboard, for example, I still have all the standard imports. I haven't changed any of that, and I have import. And I prefer to use my imports as individual classes. I don't group it in package level. And then, of course, I have to also say in my module info that I require JavaFX.controls, JavaFX.fxml, for example. So effectively, but yes, you have to type it twice. But as you know, IntelliJ means that you don't have to do much typing at all.
Yep.
And again,
okay.
It's important to understand that here, let's go to dashboard again. Here we're talking about packages. JavaFX.fxml, JavaFX.application, JavaFX.scene. But here we're talking about modules, and modules actually have more than one package in. So if we have a look at this one, for example, JavaFX controls. Oh, well, that just has scene in it. Let's look at base then. So this has JavaFX.beans.collections.event.util. So I only need to include, in my module info, I only need to include the module level. And then in my dashboard, I have to include package level, as always, as I always did.
Okay. So next question. If there were two packages, Java lang logging, Java util logging, how would I know which one I require by require Java logging in module-info.java?
So if you're using, so Java logging, let's have a look at this one, only contains java.util.logging. So it only has that one package in it. I'm assuming that the sun is internal stuff we shouldn't be looking at. So if I'm using java.util.logging, then I require the java.logging module. So if there's another logging, which is, I don't know, if there was another logging like log4j, then I wouldn't be using java.logging, I'd be using the log4j module instead.
Okay. So there are already some people complaining about too many questions. So Trisha,
Yeah,
let me know if you prefer to move on, and then if it's possible, we'll try to address questions with a follow-up email.
Yes, let's do that. Let's do a blog post on the questions. So we only have 15 minutes left. So keep asking the questions through GoToWebinar, and if we don't have time to get to the questions, we'll answer them on the blog because a lot of these questions are really good questions.
Cool, thanks.
All right, let's move on to everything else in Java 9. Convenience factory methods for collections. This is my favorite feature of Java 9, which might seem like a really silly thing, but it really makes life an awful lot easier. And I think this is something that developers are going to be using all the time. Let's take a look at what this is. Oops. So right now, what we'll find in a lot of our code when we're trying to create maybe a static list, we might be using it for test, we might be using it for production data. is we probably use arrays as list. An arrays as list gives us an array that gives us a list that we can't add values to. But what we don't always realize is that you can actually still change these values if you want to. Probably what we wanted was an unmodifiable list. But with the arrays as list, I can say list.get1 and then set it to something different. So usually what we really want is an unmodifiable list. But we tend not to do that because that's an awful lot of typing. But in Java 9, and as you can see, IntelliJ tells me I can use this, this can now be replaced with a much smaller call. All of that can be replaced with list.of. And this gives me an immutable list. So not only can I not append values to it, I also can't change any of the values. The implementation is subtly different to the unmodifiable list, but the implications are the same. It gives me a list that I can't do anything with, which is good because it means we have control over our data. It's also good because it's easier for the JVM to reason over and potentially optimize as well. This is useful in terms of lists. Where it's really useful is in terms of some of the other data structures. For example, sets. Now, sets never really had a very nice way of creating a set. So I have two values I want to put into my set, and yet I have to give it all of this boilerplate just to create that set. I have to turn it into a list, I have to put it in a hash set, and then I have to wrap that in an unmodifiable set. Or I can use set.of. This is going to be much easier for us. This might help us start to use the right data structures for the right things, because often we use lists because it's just the easiest thing to create. So I think this is super useful. You can also do the same thing, a similar thing for maps. So this code is, again, genuine code I had in my application. I really did need to create a map, a static map, which maps a string value of some kind to a mood value of some kind. And I have to put it inside a static block. And it's kind of ugly, and I was never very happy about it, but that's what you do in Java. Except that now you can say map.ofEntries. I can use my favorite IntelliJ feature, which is column select mode. Let's put this down here. We say map.entry. We use IntelliJ IDEA's most used feature, which is find and replace. Let's replace all of those. Get rid of column select. And now we have our map of entries with strings to moods. It's a bit less boilerplate. We got rid of our nasty static block here, so that's great. Obviously, if we use static imports, then we can make this a tiny bit even neater. So let's do that. And that's quite nice. That is a big improvement over what we had before. What's even better is if we have fewer than 10 entries, we can do something even simpler. We can say map.of, and then we can get rid of this. We can get rid of this. And we can have a compiler error. What did I do wrong? Map.of. I got too many? Yeah, I had too many. You've got a maximum of 10 that you can do. So then all I have to do is I just put key value pairs here. Key value, key value, key value. So I've just got rid of a lot of boilerplate there. This can be really useful, especially for test data, but might be really useful in production code too. And obviously you get compiler errors if you don't fill in the right key value combination. It gets a little bit more fluffy if your key and value are the same type, in which case I would recommend probably using the of entries version, so you can group together your key and your value so that you know that you haven't accidentally done I don't know, something like this where one of those is supposed to be a key and one is supposed to be a value. So this will make our code a lot nicer. It's not quite as nice as saying something in a groovy style way, but it's definitely a step in the right direction, and I think this will make our code a lot easier in the future. I'm going to roll that back so I don't get my compiler error. So yes, so that's convenience factory methods for collections. I really do want to get through these as fast as possible, so I will try and show them as quickly as possible. Private methods on interfaces. This might seem very silly because your interface is supposed to be your public API, so why would you need to put a private method on your public API? Well, I will show you. In Java 8, interfaces got magic superpowers. In Java 8, you can now have static methods and default methods. So your methods on interfaces might actually have behavior and not just be a definition of your API, which means that you can end up in this case where I've got duplicate code between these two methods, and I can't really do anything about that because if I extract this into its own method, let's call it get value for field. Let's call that, oops, field name. Then what I've got is I have a new public method on my interface, which is not what I wanted. What I wanted was to reshare the code between those two things without exposing it to the end users. Now in Java 9, it's as simple as that's now a private method. So Java 9 has a lot of these small features which is just going to make life a little bit easier for us as developers, things that they probably wanted to put in earlier versions of Java but just didn't have time to do it. New methods on the Streams API. Again, this is something that would have been nice in Java 8, but it's nice that we're getting it in Java 9. Let's look at, while we're here, let's have a look at something. One of the things that you can do now is you can use effectively final or final values in try with resources. You might not have realized that you couldn't do this before, but you can now do it in Java 9, and it's just a tiny improvement. It's quite nice. Now, Java 8 streams allow you to work with infinite streams. This is cool, this is great, and theoretically awesome, except that if you're working with a genuinely infinite stream, in Java 8, it's very difficult to actually terminate that infinite stream unless you put a limit on or one of the few terminating features in Java 8 streams. Now, with Java 9, this becomes a little bit easier. Now, what this code does is it reads all the lines from a file. So the file contains Twitter information. And this gives me a stream where each value, each value in the stream is a line from the file. And what I might want to do, it's not infinite, but it doesn't stop until you get to the end of the file. I might want to say, take while, let's say s is not equal to some value. Let's say there's some secret superpower in there which says I've reached the end of the file. So let's process this stream until you hit some value. Or let's assume this file, let's assume that the strings in this file start with a number and they're ordered. So for example, you have like 1, 2, 3, 4, you've got 100 that start with 1 and 20 that start with 2. So I might want to say, process this stream while S doesn't start with, I don't know, let's say number 3. So I want to process everything that starts with 1, everything that starts with 2, and then stop when I get to something that starts with 3. The flip side of this is there's another method called drop while, which allows me to ignore everything up to some point. So I might want to ignore everything that starts with 1, for example. So ignore everything that starts with 1, process the next lot of stuff, and then stop when you find something that starts with 3, for example. So, and there's a number of different ways of using this, but basically take while and drop while allow you to process infinite streams until some value is reached. So I might want to say take while running is true, and I could create a field, running is true, and then when stop is called, I could say running equals false. So process the stream while you're running. In real life, of course, this should be an atomic Boolean, not a Boolean value, etc. But this is another thing you can do. So now infinite streams are much more controllable in Java 9 using take while and drop while. Similarly, there's new methods in optional. This makes optional a little bit easier to work with as well. So if you've been reading the IntelliJ blog, you'll see that I was struggling a little bit with how to make optional effective in legacy code. Because in legacy code, we do stuff with null values we probably should never have been doing in the first place. But it was easy, so we did it. So let's take a look at an example of some of an optional. If you've been using optional in Java 8, you'll know, let's extract this out so we can have a look. Let's call this an optional. If you've been using optional in Java 8, you'll know that you can do things like, I want to say, I want the value of optional or some other default value, or go to this method and get me some default value, or you can say, or else throw an exception, for example. Those are kind of your three main things. And what they do is they will unwrap the optional and return you a mood object. In this case, this is an optional of mood. In Java 9, you can just say or, and that returns you an optional of mood, not the unwrapped mood. So let's say, let me show you an example of this. So get alternative optional value. I'll just put the structure there so you can see what the point is. This case is kind of useful if you have two methods that return optional values. So the first one, if the optional value ends up being empty, go to a different method to get another optional value. And then, of course, you can carry on chaining this and do whatever else you were going to do over an optional. So it doesn't just terminate with an unwrapped optional. So that can be very useful for some of the use cases that I've been looking at. One of the other new methods is previously, well, so the naive way of using optional is, let's have a look at this. We say if optional is present, optional, let's say do something, optional.get. Let's create that method. So this is kind of the initial way that you start using optionals. If optional is there, then do something with the optional value. IntelliJ tells you, well, that's not a very Java 8 way to do stuff. I'm going to want to copy that. IntelliJ tells you that's not a very Java 8 way to do stuff, so why don't you turn that into an if present? That's kind of fine, that's nice, it works reasonably well, except for when you wanted to do something else. Let's create that method. Then you can no longer use a functional style expression. You have to use the is present else form. Now in Java 9, you can use something more functional. Let's turn that back into our functional style expression. And we use the new method on Java 9, which is if present or else. And you give it your else condition. So if it's present, do this. If it's not present, do that. And I think this is really nice because this can really collapse down those complicated if-else conditions that I've seen a lot of in existing code that uses null values. We're running out of time, and I just wanted to have a look at a few more features. There's another value which is optional.stream. This allows you to use optionals more effectively in, not surprisingly, stream operations. If I show you an example, that might help. So I don't need you to understand this, and we'll come back to this code in a second. But what I have here is arguments returns me an optional of a string array. And in order to use that effectively inside the stream, I ended up calling the stream method. I'm sure there are more efficient ways of doing this, but this was better than the Java 8 way of doing stuff. So our three methods on stream on optional are optional.or, if present or else, and optional.stream. And they just mean that it's just going to be a lot easier to work with optionals without having to unwrap them and see what the value is first. Okay, the stack walking API. So we just had a really quick hint of this. Oh no, we were looking at monitor. Let's have a look. We know that processing the stack trace is expensive. If you want to look at the whole stack trace, it has to build the whole stack trace, and that's expensive. And sometimes what you want to do is you want to look at some part of the stack trace and maybe find the first instance of something in the stack, or maybe just find who called me. So now there's this new thing called the stack walker, which lets you lazily look at what's in the stack. I highly recommend that you look at the documentation and some blog posts around this stuff, because again, this is quite a big feature. But it's worth knowing that now in Java 9 you can lazily walk the stack, so you don't have to incur the cost of building up the whole stack trace. Process API updates. We'll go back to this code we just saw here. Oh, and here. There's a whole bunch of new features around handling processes in Java 9. There's this thing called process handle, which came into Java 9, and this gives us really useful, powerful, higher level abstraction over the processes which are running on our system. This is really useful for things like monitoring, but I can imagine a whole bunch of use cases. So here I can get all my processes, and then I can do stream-like operations on it. For example, let's run this and see what happens. I get all the processes. I want to find all of my processes. I want to find all of my processes which are Java processes, and I want to find all of my processes which are Java processes which are my code. So if I was running more than one service, this would be able to show me which services I'm running. This is super useful in terms of for example, microservices architecture, where I might want to see how many of my microservices are running on my system. So here I'm just running one, which is this monitor. But you can also do things like you can get the PID for that, and then you can process the process. You can do things with that process. So another really nice feature here is I get my current process, and I can get the process ID of my current process, which was really difficult in Java before, particularly because you didn't know which operating system you were running on, and you didn't know how to necessarily manipulate that operating system. So the new Process API gives you a much higher level way of doing sort of operating system stuff, which is really useful for things like monitoring. I knew we would run out of time. I'm going to expect some users are going to want to drop off because we're running out of time, but I'm going to try and finish this, and of course it will be recorded, so if you have to drop off, you can come back in later and see the recording. I'm just trying to see how many more things. There's just a few more things, and then we get to the summary. Multi-release jar files. Let me open up an application which demonstrates this. So multi-release jar files is a new feature in Java 9, which I think is really cool, and I wish we'd had it much earlier. This is the ability for a library to release a single jar file which contains different implementations with different versions of the JVM. So for example, people who are using Java, not Java 9, basically Java 8 and below, they will run the jar file and they will get the Java 8 or pre-Java 9 functionality. And if you are running Java 9, then when you run that same jar file, you'll get the Java 9 functionality. Now, theoretically, this is only supposed to work for the internals, for the way that the implementation works. You shouldn't get a different API if you're running on Java 8 or Java 9. I believe that might be down to standards rather than an actual implementation restriction. So I'd be really interested to see how these things are implemented by library developers. But I'll just really quickly show you the mechanics of it, because it's fairly simple. So I have a project. I'm going to write a blog post about this, about how to do this in IntelliJ, because it's quite interesting. So I have a project. This is my code. It happens to be compiled and run in Java. I have a main class. I have an interface, stack info, and then my stack parser for anything which is running on Java 8 uses getCurrentThread to get the stack trace. That's the implementation that I've chosen there. And what I've got here is I have an implementation of stack parser for Java 9, which is the stack walker that I just showed you. So obviously the stack walker will be more efficient. So if you're running Java 9, I want you to be able to run this using the Java 9 implementation. And the way that's done is my classes for the normal code goes in the normal sort of route, the normal structure of your classes. My Java 9 specific code, I don't have to compile the whole project down to Java 9, just my Java 9 specific stuff. And it goes into meta-inf version 9. And potentially you can have like 10, 11, 12 in there if you want to. What you can't have is you can't have 8, 7, and 6 because this only applies from 9 onwards, which is very sad. But you can see, so here, my stack parser is compiled with Java 8. It's my Java 8 class. And this stack parser is my Java 9 class. And then in my manifest, I say this is a multi-release jar file. And then I build my jar file. And when I run it, if I run this in Java 8, I get the Java 8 implementation, which uses java.lang.thread. And if I run it in Java 9, I get the Java 9 implementation. So, and that's just using the same jar file. So I think this is a really interesting feature of Java 9, and I'd be really interested to see if that will help libraries migrate to use Java 9 features more quickly than they would previously have been able to do. Updated deprecation. This will help us as developers trying to figure out which features we should and shouldn't be using. So let's have a look at current thread dot stop. Let's say and then you can see, maybe you can see, I'm colorblind. This is actually crossed out in red as opposed to in black. And it says it's deprecated and marked for removal. If we look at this, the deprecated annotation now has 2 new properties. The person who deprecated it can optionally say which version it was deprecated in and is this code going away. Theoretically, you can deprecate something in a kind of, well, I don't really use this, but I'm not going to get rid of it. Whereas now you can flag it for this method is going away. So if you're using it, you really do need to stop using it right now. And this is going to be really useful for helping us to move away from using old code and figure out how important it is that we do that. For example, if we use the other version of this and we look in, it says it's deprecated, but it's not going away. It's a small fix, but it makes life a bit easier. HTML5 Javadoc, dragging Javadoc kicking and screaming into the 21st century. This allows us to generate our Javadoc in HTML5. So you end up with something which looks more like this. That's kind of nice and, you know, it's cool. But what's most interesting about it is this feature, Javadoc search. And I can do camel case search like I'm used to from having IntelliJ IDEA. And I can search for the classes I'm actually interested in inside Javadoc. This is so much better than having to open it up into frames and then do a find in page just to find something that I know is probably there and I just really want to be able to get to it. So this is a really, really nice feature. Again, one of those small things which has come into Java 9. It's just going to make life a lot easier for us. Yes, so that's that. JShell. We are way over time, so I don't have time to demonstrate JShell, which is really sad because I never have time to demonstrate JShell. But this is the REPL, and you'll be able to see these links when we put the slides out later. JShell allows you to run from the command line, so I can run JShell from the command line, it's something that comes as part of Java 9, obviously. So I'm going to run it from here, and I can say system.out.println. Oops. I get tab completion, which is kind of nice because I'm lazy, and I can say hello, and I don't need a semicolon, which is amazing. But there's loads and loads of stuff in JShell. What I think is really interesting from an IntelliJ point of view is we do have a tool which uses this. So we have JShell console, which allows us to do something similar. So we get system.out.println hello, and we can do the same thing. So this allows us to play around with functionality well before we actually have to put it into our production code. So we can run snippets, and we can potentially create scripts and so forth. It's a really interesting feature that we haven't had in Java before, and from our point of view, it'd be really useful if you use this. It'd be really useful for you to feed back to us, to tell us, well, obviously if there are any bugs, but what's more interesting is what sort of features do you want to see, what kind of things, how do you use it, how can we make your workflow easier. Okay, well over time. Let's now summarize Java 9. People are afraid of Java 9 because they've been reading for years that code is going to break. So that's what people are afraid of, that your code is going to break because of the encapsulation of internal APIs, because of a number of different things. Now, of course, the key thing to do is try it out and find out whether your code is going to break. Don't just wait and see, because no one's going to be able to tell you that your code is broken and in which way it is broken. It is well worth trying it out now, especially now that Java 9 is out officially and it's not an early access release, which is going to change. There are a number of things which could contribute to your code breaking. There's a lot of things which are going away. So removal of deprecated GC combinations, for example, removing various tools, removing various launch time flags, deprecating the applet API. These sorts of things, they're going away. So, and the encapsulate most internal APIs is the thing which basically makes some things that you were using potentially look like they've gone away. What's more interesting that might cause unexpected breakages is some of these features which might change the behavior of your application without you realizing it. So they did a lot of work on the JVM logging. So if you've got anything like reports running, grepping for various log statements or anything like that, those might not be there anymore in Java 9. Things like G1 as the default garbage collector, I don't think that's really going to impact a lot of people, because if you don't care very much about your garbage collector, so you're using the default, I don't think changing the default will make a big difference. And if you do care about your garbage collector, you've probably tuned it to within an inch of its life, so you don't really care what the default is because you're not using it. But it is worth being aware of. To me, one of the gotchas that certainly got a lot of tools and frameworks and libraries is the new version string scheme. So Java 9 is not Java 1.9. Java 9 is Java 9. So if you're doing any parsing of the version string and taking the 1 point off the beginning to find out what version it is, that's not going to work with Java 9. You are going to get like an index out of bounds exception or something. You can't take the 1.9 off the beginning because it doesn't exist. And of course, this is going to be even more interesting when Java 10 comes out, since they're talking about calling it Java 18.3. The tools, the libraries, the frameworks, continuous delivery things, the stuff that we rely on are still evolving for Java 9. There's been a lot of churn in Java 9 in the last year alone. It hasn't been super stable. The churn has been good because it's made Java 9 better and stronger for what it is, but some of the tools and frameworks were waiting for it to settle down before becoming Java 9 compliant. So do try it, particularly in your continuous integration environment. Make sure that CI still works. Make sure that the libraries are working the way you expect them to. So, and then you probably need to upgrade to the latest version of some of the things that you're using. You don't need to modularize your code in order to use Java 9. This is a common misconception. You don't need to put module-info.java into your code in order to use the collections factory methods, for example. You don't need to use any of the modularization stuff if you want to just use the features in Java 9, like new methods on optional, new methods on stream. So if modularization isn't going to give you any benefits, if using the new module system isn't going to give you any benefits, don't use it, because it is quite a lot of work. One of the reasons why Java 9, why the module system was pushed out to Java 9 from Java 7 is it took them a long time to modularize the JDK itself. So it is a lot of work, but you don't need to. So don't do it if you don't have to. The game. You do get good design using Java 9. It does encourage encapsulation, separation of concerns, good object-oriented design. You get a cleaner design from using it. You also get better security from that as well. So this is definitely a good thing. It encourages new ways of working using the REPL, using the Reactive Streams API, and things like that. But I think, for me, Java 9 is just a bit nicer to write code. It's not the sexiest strapline for a version of Java, but that's what it is. There's things like the new methods on optional and stream, the collections factory methods, the reduction of various bits of boilerplate, being able to use effectively final variables in try with resources, the ability to use the diamond operator with anonymous inner classes. These are all tiny things, but they just start to sweep away some of the boilerplate and some of the noise from working with Java. So this is kind of the main benefit of moving to Java 9 from my point of view. And of course, it's a good idea to move to Java 9 because Java 10 is allegedly going to come out in March, this March coming. So we're going to need to have adopted Java 9 and got all our libraries upgraded so everything works with Java 9 so that we can use all the cool features which are coming in Java 10, like local type inference and some of the other cool stuff which is going to be in Java 10. Okay, so as usual, I am extremely way over time. This link will point to this video when this video is online. This link points to a bunch of stuff like documentation for JDEPs, JLink, all of these tools that I've mentioned, the links which were mentioned earlier on in terms of tutorials for JShell, even other videos of this talk where I've been able to go into more depth on reactive programming, more depth on JShell perhaps. So do follow that link and find more resources there. I will take questions, but I fully expect that people have already disappeared because I'm enormously over time. Andrea, are there any questions?
Yeah, I wish we had more time for questions, but what we can do is to try to address most interesting question in the blog post, which we'll publish along with the video. And yeah, and everyone who registered will get that email. And yeah, that's it. And no doubt, it's quite challenging task to explain all the features of Java 9 in just 1 hour. So thanks, Trisha. You just made a great job.
Thank you. It's quite difficult when Jigsaw really should take about 3 hours in its own right.
Yeah. So thank you. Really appreciate your time, and thanks everyone for joining us.
Thanks a lot. Bye bye.
Okay. Take care. Have a good day.